I've been talking for a while about 6 trig functions, saying to you that you currently only know 3 trig functions, sine, cosine, and tangent, but that there are indeed 6. Today you're going to learn 2 things. The first of those 2 things is the other 3 trig functions, secant, cosecant, and cotangent. And then we're going to learn what a radian is. Those things up on my clock at the top of the board are radians, and today you're going to finally be exposed to them. Those are the 2 goals that I have for today. We're going to start by defining a secant. A secant, a cosecant, and a cotangent, they are your inverse or reciprocate functions. Not, I say inverse, you say switch, I have the answer, you give me the question inverse, but top to bottom inverse. These are for multiplicative purposes. When I want to multiply something to get 1 to be the answer, these are the 3 functions that I'm going to use. So my secant function is the reciprocal of the cosine function. And that means also, I'm going to change this to an arrow, that cosine can be thought of as a 1 over secant. They are reciprocals of each other. I can reciprocate either one of them and call it equal. As long as one of them is the denominator of a fraction, the other one will not be. That means that if I take a cosine and multiply it by a secant, my answer will be a 1. Cosecant is going to be the reciprocal of a sine function. I'm also going to change this to an arrow because it's an equivalent statement. And that means that I can also call sine the reciprocal of a cosecant. Now you'll notice the abbreviations that I'm putting in here. That's important to note because you need to recognize them. The abbreviation for secant is SEC. The abbreviation for cosecant is CSC. Finally, a cotangent is the reciprocal of a tangent. This one has 2 alternate statements. So I can call it a 1 over tan. And like everything else, I can likewise call a tangent a 1 over cotangent. But this one is slightly different, not cosine, cotangent. Go away. In the sense that, remember, I could also call tangent sine over cosine or y over x. Talked about that in the video and last Friday. That means I can call cotangent cosine over sine. So tangent and cotangent have a lot of manipulative possibilities. A tangent can be 1 over a cotangent can be 1 over a tangent can be a sine over a cosine, and that means a cotangent can be a cosine over a sine. If I were thinking about this in terms of my unit circle, I'd be calling this x over y, where this was y over x. And when I say that, just to make sure you're still with me here, what I'm talking about is when I drew my unit circle, and we put in that unit circle a point named P whose coordinates were cosine, comma, sine. We came to that conclusion by making this thing into a triangle and calling this x and calling this y. Remember, my radius was a 1, and that meant that the x coordinate is really the adjacent over the hypotenuse or the cosine, and the y coordinate is really the opposite over the hypotenuse or the sine. That's what we learned before break. Does everybody remember it? And I actually taught you that. Okay. So that's where these are coming from. Likewise, again, since tangent is opposite over adjacent, it's y over x or sine over cosine. And flip those, and I get cosine over sine, or x over y. That's what I'm referring to there. Okay, so moving right along, we're going to actually try this in the same exact fashion that we did our basic trig functions on the first day of trig. Using SOHCAHTOA trig, we're going to find all 6 trig functions as fractional ratios for this set of problems. This right here is a 3, 4, 5 right triangle. starting pretty simple for you there. And when I look at this, and I'm talking all 6 trig functions are going to be in reference to A. So this 3 is going to be known as the opposite side. This 4 is going to be known as the adjacent side. And the 5 is going to be my hypotenuse. Is there anybody who doesn't know where I got those from? Excellent. And when I go to do the sine, cosine, and tangent, I do it exactly the way I did before, which is to say, I take the opposite and put it over the hypotenuse, 3/5, and call it the sine. I take the adjacent and put it over the hypotenuse, 4/5, and call it the cosine. I take the opposite and put it over the adjacent, or the numerator, and put it over the numerator, and I get 3/4. And then I could flip all 3 of those to get their reciprocal functions. When I flip sine 5/3, what I get is cosecant. Now, one of the things I want to caution you about is I will not always set these up side by side. I did for this one, but I don't have to. So when you're flipping that sine function, you need to make sure you're looking specifically for the cosecant function to give it the answer. Because sine is the reciprocal of cosecant. It's not the reciprocal of whatever's next to it. Does that make sense? So just use a little bit of caution there. If this were a quiz or a test, I'd be looking to see if you were using that caution. That's the type of trick I would throw in there. I have strongly encouraged you to watch for details. That's an important one, that I'm putting the answer in the right place. When I flip 4/5, I get 5/4. The reciprocal of cosine is indeed secant, so I'm putting it in the right place. And when I flip 4/3, when I flip 3/4, I get 4/3. And the reciprocal of tan is indeed cotan. Not bad? Okay. Next thing I'm going to do is I'm going to help you and remind you that this is a Pythagorean theorem issue and that the hypotenuse is what's missing here. So my first goal is to find 12 squared plus 15 squared equals the hypotenuse squared. I'm going to call it h. And I'm going to ask you to find h in radical form. And you should have gotten that h was 3 rad 41. That's going to go right here. Now, as soon as I see that radical in the hypotenuse, 2 things should come to your brain. Caution, caution, caution. What am I thinking? That's right. I'm going to have to rationalize when I do sine and cosine because that radical is going to be on the bottom. Once again, I'm going to strongly encourage you to rationalize after you get all the answers down. And that's most important right now because remember, I'm going to be flipping these things. So I want you to just write them down first and then go back and rationalize second. I'll show you why. When I go to write these down, again, keeping in mind I'm always in reference to A here. So this 12 will be my opposite, this 15 will be my adjacent, and 3 rad 41 will be my hypotenuse. The sine of this function, opposite over hypotenuse, is going to be 12 over 3 rad 41. The cosine of this function, adjacent over hypotenuse, is going to be 15 over 3 rad 41. And the tangent of this function is going to be 12 over 15. I'm going to flip them right now. And the reason I'm going to flip them right now is because when I flip them, that 3 rad 41 goes to the numerator and is no longer going to cause me grief. I just did it. What did I do? I did exactly what I cautioned you to be careful of. I looked after the fact, but it's exactly what I just told you watch for. I put it in the answer for secant, and it actually belongs right there. Sine is the reciprocal of cosecant. Did you catch it? Do you see how easy it would be to miss it? I'm lucky I caught it because you would have killed me if I didn't later. Okay, moving right along now, I'm going to flip this one, and I know that cosine is the reciprocal of secant, so I'll take this answer and put it right here. But the beauty of these reciprocal functions is if I remember not to rationalize until later, am I going to have to rationalize these two? No. That radical just moved to the top all by itself. This one is just going to flip straight upside down to 15 over 12. And of the 6 functions, really with a radical on one side, you should only ever have to rationalize 2 of them. Go ahead and rationalize these two. Make sure you're only rationalizing the rad 41. That 3 is not causing me any problems. So in other words, I don't need to multiply by 3 rad 41, just the rad 41. You can also get rid of the 3 in both cases because it reduces with the 12 and the 15. Go ahead and give that a shot. Did you get what I got? Any trouble with those? Those would be my final 6 answers. And again, that is the 6 trig functions. The next thing we need to consider as we're talking about these trig functions is because we now have 3 new functions, there are 3 more things that they could ask me exact values for. So I need to know both what the sign, positive or negative, on my answer will be for these 6 functions, but also what the exact values for these 3 new trig functions will be. So I'm going to take the exact values chart that we had from 3 or 4 pages ago, and I'm basically going to reciprocate it and rationalize it so that my chart gets a little bit more expansive. I'm going to start with the ASTC, which in the previous lesson we talked about all students take calculus, or all previously 3 trig functions were positive in quadrant 1. Students, or sine, is the only function in the second quadrant that will be positive. Take, or tangent, will be the only function in the third quadrant that uses a positive valued answer. And calculus, or cosine, is the only function in the fourth quadrant that will have a positive answer. Now that I've added in 3 new functions, I'm going to keep that same exact acronym. It's just going to take on a slightly different meaning. And that slightly different meaning is going to go something like this. I'm still going to have sine, cosine, tangent, cosecant, secant, and cotangent to deal with in all 4 quadrants. But I'm going to take those and I am going to put them item by item in each quadrant so you can see them very carefully. Okay, in each quadrant, here are what the answers will be. Everything is positive in quadrant 1. The all is still true. In the second quadrant, sine is guaranteed to be positive, and cosine and tangent were already guaranteed to be negative. What happens to the sign of a number when I turn it upside down? When I invert it, when I reciprocate it? Does it change from negative to positive, or does it stay whatever it was? If I take a number like negative 1/2 and I invert it or reciprocate it, is it still negative? So any number that was negative will stay negative, and any number that was positive will stay positive. So that S now stands for, in quadrant 2, sine and its reciprocal will be positive. Everything else will be negative. In quadrant 3, we had already said sine and cosine would be negative, but tangent would be positive. And what we said just a moment ago was reciprocating does nothing to the signage. So all of the reciprocal functions will be exactly the same. So that T now stands for tangent and its reciprocal will be positive. Everything else will be negative. And last but not least, in the fourth quadrant, we were already guaranteed that cosine would be positive, tangent and sine would be negative. We're going to take that another step and say the signage of the reciprocals will stay exactly the same. And so C now stands for cosine and its reciprocal will be positive. Everything else will be negative. Still good? Okay, I'm going to stop my video right there because I'm down to about